Hey everybody, this is your calculus lesson on trig, and one of the most important things you need to remember is degree mode versus radian mode. Some of your most common ones are listed down here below, but think about 45 degrees, and then this one would be like pi fourths. There's going to be a whole list down here. Degree has the little degree symbol, like kind of like in Fahrenheit and Celsius. Remember that if you need to press the pi button, go to trig 5 at the ends. So if I wanted to drive, I'd have to hit the pi button. And there's a menu. It's a little symbol. Now I bet that's square over 2 because it's my teacher later. I did 45 the pi button 2 degrees. I get 0.7, which is square root of 2 over 2. That's a whole nother subject or topic that we'll talk about. But you'll need to have your notes. Okay, so it's basically any part of trig that you were taught in pre-cal. You're going to talk about radians and degrees, evaluating trig functions, graphing them, the addition formulas like sum and difference, the half angle, and solving trig equations. So while you're studying this, there are many parts from pre-cal that are covered in this part of calculus. And then even later on in calculus, you're going to have other trig parts. Later in calculus, there are more trig parts. Like when we get to limits and some other things. Okay, so for your circle of radius r with your central angle of theta, radians, subtends or creates an arc whose length is s, then your formula is s equal r theta. Okay, so what does that look like? It's a central angle, so we're just going to make a little Pac-Man, and this is going to be our arc length s, and inside here this is going to be our little theta. Okay, so arc length is a distance. It's a distance. Now, when we think about our conversions, 1 degree is pi 1/80th radians. 1 radian is 180 over pi degrees. Remember, pi can be thought of as 180, so when we convert, it's like multiplying by 1. Now, what we usually do is say pi over 4 is like 180 over 4, which is really 45 degrees. That's the easiest way to convert it, because not only do you think of pi as 3.14 or 22/7, but also you can think of pi as 180. Now, if you want to be completely official about it, you'd say, well, if I have pi over 4 and I want to go to degrees, then I put pi over 4, and then I've got to multiply. Well, if pi is on top, then this pi has to be on bottom for them to cancel. And then you go 180. So that's how you can actually see you get your 45. Now, common ones are 30 is pi 6, because you can think 180 divided by 6. And you can see how most of these work out. 180 over 4, 180 over 3, 180 over 2, just exactly 180. Which is half a turn. 360 degrees would be all the way around, which is 2 pi. They call that 1 revolution, which is 1 full turn. Notice the bigger the denominator, the smaller the angle. Now I have this little chart here, and I've already talked about the conversion with the proportion, but I've got this little chart here that could be useful maybe. For 0 radians, that's the same as 0 degrees. The sine of 0 is 0. The cosine of 0 is 1. The tangent would be 0 because it's 0 over 1. So tangent is sine over cosine, or you could think y over x. Remember, sine is like y, cosine is like x. And then when you do reciprocals, cosecant is like 1 over sine, secant is like 1 over cosine, cotangent is like 1 over tangent, or you could say cosine over sine. Okay, and then for pi halves, that's equivalent to 90. And so, like, if you think of the unit circle, 0 degrees is here, and as you work your way around 0, then pi halves is there. Well, at 0, it's the ordered pair 1, 0. So we think x, y, or cosine, sine. X is 0. I'm doing 0 degrees. X is 1, and y is 0. Now for pi halves, we have 0, 1. So cosine is 0, and sine is 1. And you can work your way around. If you're trying to divide by 0, it doesn't work. So that's why it says not defined. Now when you're at pi, that's the ordered pair negative 1, 0. So your cosine would be negative 1, your sine would be 0. Negative 1, 0. And for 3 pi halves, that's this one, where it's like 0, negative 1. So your cosine is 0, your sine is negative 1, and then there's the rest. So what you will see is that for 0 and pi, your cosecants are not defined, but for tan and, well, for tangent and secant, pi halves is not defined. So you're going to have asymptotes for 2 functions that match. So cosecant and cotangent match, and tangent and secant matches. Okay, more information is you have pi 6. So those are just like the regular quadrant parts. But now pi 6 is pretty common, which is 30 degrees. Sine of 30 is a half. Cosine is square root of 3 over 2. Tangent would be square root of 3 over 3. Pi force is like 45 degrees, so both of these are square root of 2 over 2, and this one's 1. And then these are listed. Pi thirds is basically the opposite of pi 6. These two match and those two match. And these two match and those two match. These two and those two. So that's just a table to refer to. I know maybe at this time you may not remember that stuff, but we'll get into it. So that's just a table to refer to. Here's some common decimal equivalents. Square root of 3 is 1.73. Square root of 3 over 2 is 0.866. Square root of 3 over 3 is 0.577. That's the same as whatever 1 over square root of 3 is. And square root of 2 is about 1.414. Square root of 2 over 2 no, that should have like 1 over square root of 2. They're both the same thing. And this is 2 square root of 3 over 3 is like this. Okay, there are lots of notes in this section because there's so much of trig. Now, sine is the same thing as saying y over r. Cosine is x over r. Tangent's y over x. Cosecant is r over y. Or you could just think 1 over sine. Secant is r over x, or you could just think 1 over cosine. And this is 1 over tan. Or you could say cosine over sine. Okay. For the addition formula, there's like the sum and difference of two angles that add up to certain thing. Like for example, if we did 45 degrees plus 60 degrees, that's 115 degrees. And if you need an exact answer, you would have to break down 115 into this part and that part and do your sine and cosine. Now, you also can think about A being bigger than B, so when you do A minus B, you get a positive answer, or that it overlaps. So for example, if we had one that's 45 degrees and one that's 30 degrees, the difference is 15. Okay, so for your sum formula, that's going to be your statement. It goes sine, cosine, cosine, sine, same sign, first, second, first, second. So what that means is if you have sine here, you'll have sine, cosine, cosine, sine. A is first, B is second. So you go first, second, first, second. So that's that. And because it's sine, we have a plus. It's the same sign. So when we do minus of this one, it'll be a minus there. So here was back to a difference formula with sine. We go sine, cosine, cosine, sine. Same sign. This is minus, this is minus. So those are related. Now there's also a cosine, which goes, it's really like a chant. Cosine, cosine, sine, sine, opposite sign. First, second, first, second. So this is plus, which means this is minus. This is minus, which means that's plus. For cosine, it switches. So there's a little paragraph you can read. There's the half angle ones, which is where it starts to get a little more complicated. There's the squareds, which are even more complicated. And there's the half angles with the trig function squared, which is pretty complicated. And then you have the half angle formulas with a plus or minus depending on the quadrant of your angle divided by 2, which are these formulas. And these are plus and minus square roots. And for the second and third tangent ones, there's no plus or minus on purpose. Okay, let's get into it with doing problems. Okay, so say we have a circle who has radius 3. How long is the arc that goes for 2 pi thirds radians? So for 2 pi thirds radians, you use S equal R theta. Theta has to be in radians, and so this would be 3 times 2 pi divided by 3. It's really convenient, those 3's cancel, and we get 2 pi. So that's how you do A. Now for this one, for 30 degrees, you got to figure out what equivalent that is. So one way is just mentally say, oh, I know it's like pi 6 because 180 divided by 6 is that. If you don't remember that, that's fine. You put 30 on top. I know pi has to be somewhere. Well, pi can't be on bottom. pi has to be on top. So that means 180 is on bottom. And then you could do your cancellation of your zeros, and 3/18 is the same as 1/6. But the 1/6 pi really looks weird to me. We always just say pi 6. So that's how it looks natural. Okay, so that first step was get your theta to be in radians. Theta must be in radians. So then we do S equal R theta. So we have R is still 3. Your theta is now pi 6. So this would be like 3 pi 6, which is the same as pi halves. Reduce your fractions, and that's your answer. Okay, so for this one, our first step is we need to get our units consistent. So if we have a 1 meter diameter, that means that the radius is a 1/2 meter. And that means it would be 500 millimeters, or we should say 50 centimeters, because we need to go to centimeters. Okay, so the first thing, if you see rolling a 1 meter, then that's going to be like 100 centimeters in a meter. So a half of that would be 50. So the diameter is 100, which means the radius is 50. Okay. So then from there we use S equal R theta. Our S is the distance it went, which was 28. Our radius is 50. And our theta is the angle. So you divide by 50. So theta is 28 divided by 50. It first wants it in radians. And so let's do 28 divided by 50 as a decimal. 28 divided by 50 is 0.56. And they say round to the 10th, and so that'd be 0.6. So that's your number of radians. Now, before, when we said, oh, if you have like pi 4s, then how do I make that degrees? How we did that is if you have pi over 4, then you got to put pi on bottom for them to cancel. So then your pi's cancel and you get 45. Why I'm saying that is because here we have a theta that's not in terms of pi, but I needed to know whether I put pi on top or bottom in this conversion. And so by remembering something simple, I can remember the formula. So it's 0.6 times 180 over pi, 0.6 times 180 divided by, there is a pi button, and I get 34.377, and then that's 34 degrees. They want the nearest degree. So round down. Okay, from there you're going to have different trig functions, and you're going to have different intervals. So what you have to remember is that sine is the opposite over the hypotenuse cosine is the adjacent over the hypotenuse, and tangent is the opposite over the adjacent. So when we start, I draw a little plus sign, and in my case, I'd go from pi halves to pi. Here's 0, here's pi halves. I'm not in quadrant 1, I'm in quadrant 2. So I just draw a random triangle touching the origin, bringing it down like that. I don't know the angle of it. Okay, so just put it in that quadrant. This part would be 3 pi halves, and that's 0, which is 2 pi when it loops around. So pay very, very close to your interval, because cosine is positive there and there, so that means it's negative there and there. Sine is positive there and there, which means it's negative downstairs. Tangent is positive where these are positive or both are negative. So that's why, like, sometimes you're going to have some fractions are positive and some are negative. And the most common mistake is a sign mistake. So what we do is we try to eliminate our mistakes. We look at what quadrant we're in, and this is our angle right there touching the origin. Our opposite is 5, so that's across from there, and across from the 90-degree angle is 13. Now what we have to do is do our Pythagorean Theorem, or just use common sense. 5 squared plus x squared equal 13 squared. You could use repetition if you know it's basically going to be 12. 25 plus x squared equal 169. X squared is 144. X is plus and minus 12. Ooh, plus and minus. I wonder which one we use. We're on the left side, so we use the negative. Don't use positive if you're on the left. Okay, so then for tangent, apparently they're asking, and it's opposite over adjacent. So this is your opposite, and this is your adjacent. The hypotenuse is across from 90. So your tangent is opposite over adjacent. 5 over negative 12, which is the same as negative 5/12. Cosine is the negative 12 over 13. So now as far as these numbers, you're going to have some common Pythagorean triples. This is not like the complete list, but you have 3, 4, 5, 8, 15, 17, there's 5, 12, 13, and there's some more. And on any of these, you can multiply by 2, so this would be 6, 8, 10, 16, 30, 34, 10, 24, 26. And then there's more, but those are the common ones. And so that's why when I see a 5 in the numerator, a 13 in my denominator, I'm like, hey, I know that's going to be 5, 12, 13. If I did the Pythagorean Theorem, I'd get 12. And I just have to make it negative based on where I am. So the question is, where are you? Are you in quadrant 1, where everything's positive and happy? Are you in quadrant 2, where I was, where cosine was negative? Are you in quadrant 3, where everything's negative except for tangent? Or are you in quadrant 4, where sine is negative and tangent is negative, but cosine is positive. So where are you is like the first question. And based on that, you're going to have different answers, or at least different signs. SIGN, no pun intended. Okay, so tangent is 8. Where am I? I am between 0 and pi halves. Tangent is 8. I can write that as 8 over 1. And that is opposite over adjacent. Hey, how do I know what to put where? Well, here's your angle. Opposite's right here. Adjacent's right there. Now this one has no perfect number right there for your Pythagorean theorem. So you could say x squared plus y squared equal r squared. Ooh, that's a bunch of variables. You could say 1 squared plus 8 squared equal r squared. So you have 1 plus 64 equal r squared. I got 65. So r is plus and minus square root of 65, isn't it? Oh yeah. The radius always has to be positive. Radius always must be positive. On the other hand, x or y could be positive or negative based on where you are. So sine is the opposite over the hypotenuse. So that's the 8 over square root of 65. Cosine is the adjacent over the hypotenuse. So 1 over square root of 65. Now, again, I can't tell you why different publishers do different things. We do use the same book that MCC uses and some other colleges, but you may remember in pre-cal you weren't allowed to keep square roots on bottom. So just real quickly, you had to rationalize it, saying square root of 65 over square root of 65. So that is 8 square root of 65 over 65. That really does look more complicated. I like it in this form that you're able to put it in. But remember, pre-cal sometimes wanted it in this form. So just depends on your publisher and your book. With pre-cal, we use Sullivan. We also use Pearson, and most of them want it rationalized, but in calculus we have the Thomas calculus. You can't see that. We see Thomas calculus, and that's when it's okay to have square roots on bottom. So that's a good thing. Okay, so here we are. These are the problems I like the most in trig, because it's like, where are you? Life 360. I am between pi and 3 pi halves. Scavenger hunt. Okay, so now I'm down here. What happens down there? Well, we know that tangent is positive. We know sine is negative. We know cosine is negative. Okay, sine is negative because it's below the axis. So, since below x-axis. Cosine is negative since it's left of the y-axis. So just get used to that. Like, where are you? Because you have to put your triangle in the right spot. Now, this little weird thing right there means basically, where is it? X belongs to what interval? X is between pi and 3 pi halves. So right there. Okay, so now that we did that, we think, oh, okay, we've got cosine. Oh, what did we say about cosine again? Adjacent over hypotenuse. Tangent, opposite over adjacent. Sine, opposite over hypotenuse. So here's our angle, and we know the adjacent is there, the opposite is here, the hypotenuse is 25. The hypotenuse cannot be negative 25. The hypotenuse and the radius can never be negative. So that means the cosine part, like the negative 24, has to be here. Well, I bet that if we do the Pythagorean Theorem, we're going to get plus and minus something, and we know it's got to be a negative, because here I'm down. I'm downstairs. So let's do the Pythagorean Theorem. We know we have x squared plus y squared equal r squared, and that's negative 24 for x and 25 for r. So then you can do this, 576, I think. 24 squared. Yeah. Same thing as if you have negative with parentheses. 625, I believe. Yep. Then minus that one, 49. Y squared equal 49, y equal plus and minus 7. Oh, so it could be either one. Which one is it? Oh, where am I? I'm down here. So it's got to be negative 7. So then for tangent, why would this have positive 7 and 24? Oh, well, we have tangent positive. Well, why does that make sense? I've got negatives. A negative 7 divided by a negative 24 gives you 7 24s. So that's why that works out. And then for sine, we have the same opposite, negative 7 over 25. That's fun. Probably not to you. But it's something you got to do. Okay, now we have graphs. This is actually a perfect stopping point for this video. So I'll do more of these on a different video. Hope you have a good day.